So for those of you who are new, I'm Dr. Pamela Gay, and I am the principal investigator who runs a citizen science project called CosmoQuest. And we spend our time looking for new and interesting ways to get people just like you engaged in helping us map out our solar system. Normally, when I come to you on this stream, there's a beautiful studio background behind me, or at least a fish tank. My normal camera went bork, so tonight you get to see my bookshelf of arts and crafts supplies and stuffed animals. It's been the kind of week where we've suffered what we're now calling the CosmoQuest curse, where in the past 10 days, my computer self-destructed, Joe Myers, Big J, his computer self-destructed, and Matt Richardson, who's the other streamer on this channel, his computer self-destructed, but all in completely different ways. So I apologize that our streams have all been a little bit weird over the past 10 days. I'm hoping I can make up for all of this evening by doing awesome and cool things. So I see Paranor asking, did you get a telescope put together? Yes. On Sunday, Big J and I put together a Celestron Omni XLT telescope. I'm hoping that we'll get a clear night this week, that I'll be able to get some images through that telescope that I can share out with this group. So on this channel, you can find me on Tuesday nights doing various programming projects, on Wednesdays and Fridays at 1 p.m. Eastern, 6 p.m. London, and that would be 10 a.m. Pacific. You can catch Matt Richardson working out a variety of different astronomy problems. And if you don't make all the streams, we're happy for you to make whichever ones you can. In addition to telescopes on Sunday with me and Big J, this stream, Matt Richardson, Big J is also looking to add a how to learn how to code stream that will probably be on Friday nights. We're still working out the details. We're slowly growing this channel. We want this to be your space to learn space. And stay tuned. We have some really cool plans coming up for April. And that's all I'm going to say right now. So one more announcement before I get things started. As part of my job, I get to travel the world. And one of the big trips I get to make is I'm going to be going to Amsterdam in the near future. And I'm getting ready to pull up everything so I can share it. I have a meetup planned in the city of Amsterdam on February 18th, and you are all invited to join me. I'm going to stick the information for this into the chat, and you're all invited to come join me. And I see you commenting that Eddie was helpful as always on assembling the telescope. Eddie is our office dog. He goes to work with me most days and lives with me. He's my dog, but really he loves everyone universally, and he's our office dog. Yeah, he helps with telescope assembly. Hey, Embury. Hey, just no one. Again, such a sad username. Welcome everyone who's joining tonight. If any of you are in Europe, one, you're up really late. And two, I hope that I can see you in Europe. And there's actually Eventbrite information. So for those of you who don't have Facebook, I will go ahead and I will also drop in the Eventbrite link. So that should give you all the information to find out all about the event that we're going to be doing on February 18th in Amsterdam. So one of the reasons that we've been getting telescopes that you've seen us assembling is Big J and I are working on writing software that will allow people to analyze what's called photometric data. This is where you use a digital detector that is black and white, not color, because you're trying to accurately count photons, not make pictures. Well, you make pictures, but you use filters to very precisely block out exactly what wavelengths of light you want to see. And with these photometric images, which means measuring photons, we are able to do things like measure the distance to certain kinds of stars, pulsating variable stars. We're able to start to understand what are the different populations of stars in different places. We can do a whole lot of cool science just by counting how many photons comes from this object or that. One of my favorite things is pulsating variable stars. And what I wanted to do was start developing a simulation that will allow people to see how it is that these stars change in brightness and color over time. This probably isn't going to be a one evening thing to do, but that's okay. We have many Tuesdays stretching out in front of us. Now, just like I did with the crater simulation that I worked on, I'm going to do this in the processing language, which is a special framework for essentially using bastardized Java. So I have no clue if I'm going to have a camera when I switch which kind of displays I'm using. If I don't, I'll switch over to this camera in a moment. So bear with me for a second. Oh, wrong screen. Let's go to that screen. Yes, that worked. Okay. So I have figured out how to get my screen. I have figured out how to get me. What I don't have is an accurate title of what it is that we're doing here today. So let me change what I have up there for topic. So what we're working on is variable stars. Okay. And may you never have your computer completely and violently die on you, because you lose all your settings and it's not fun. Okay, so processing. This is a programming environment that you can download entirely for free at processing.org. And it works on pretty much any platform. I have yet to find a platform it doesn't work on. I'm sure if you have like some weird ancient SparkBox Unix system, like a SparkBlade or something, it might bite the dust, but so far it's worked everywhere I've tried to get it working. Don't challenge the universe too hard. The universe does like to prove me wrong. So here is my basic startup window. And the way this language works is I'm actually going to cheat and open up the file I worked on last so that I can make sure I get all of this stuff right. And I'm going to slide that off and be a sneaky person. So the first thing you need to do is there are two parts to every processing file. There's the setup part, and this is literally where you set stuff up. And then in addition to the setup part, you have the drawing part. And the way this works is you set up your canvas, and then once you have it set up, you create a looping activity that goes through and does the same thing over and over and over. Or you can tell it not to. You also do have that freedom. So the first kinds of things that you want to set up is when you're defining your canvas, you want to give it a color. We're going to give it a color that is equivalent to the blackness of space. And I have a tea kettle that keeps going off every few minutes, reminding me that I meant to make tea. So I'm going to pour water into my cup and turn off my tea kettle. Okay, so you guys can answer, you guys can ask me any questions you have as we go. I'm looking to follow along on the chat as best I can while I work on doing this. So I'm going to start off, but yes, Paranor, tea is very important. Tea is the thing that makes evenings go. So I'm going to make my background the blackness of space. The next thing that I'm going to do is I'm going to set the size of the field of view that I'm working with. And this is in pixel space, and I'm going to make this not too big. I'm just going to do 600 by 600. I'm currently choosing to make it square because I'm thinking I might even add a light curve across the top eventually. But for now, I'm going to probably start off just having my pulsating star in the very center of this. Now, the other thing that I want to do is, like I said, this is an animation, and animations have frame rates. So I'm going to give this a frame rate of 10 frames a second. So at this point, if I tell it to go, it's going to create a black box. There we go. Going to create a black box where you can't see it. So I've correctly set up my canvas. It's not the most interesting thing I've done today, but it worked. You should, in general, always check each of your steps as you go to make sure everything is working. Yes, Canada Kim, Earl Grey hot, no additives. That is my early in the day. Currently, I've had to kill the caffeine if I ever wish to sleep, which is the saddest thing. Ooh, I didn't kill the caffeine. I did not grab what I meant to grab. Okay, this is double spiced chai. So I have spicy Indian black tea leaves right now. Okay, anyways, distractions. I have a black canvas. So I've created the blackness of space. Now, since I'm going to be making a circle, circles are ellipses. So I'm going to go ahead and I want to set my colors for these things. And I'm going to do it in this box just as a completely reasonable starting place. And I'm trying to figure out exactly what color I want to use. Let's for now just start off with white. It's lame, but we'll get more complicated colors as we go. I'm going to work on just one variable at a time or completing one task at a time and test what I'm doing. Okay, so I'm going to draw a circle that is filled with white, and I'm going to outline it in white. And I'm going to make this ellipse, which apparently I can't spell, ellipse, there we go. I'm going to make this ellipse in the center of the screen. Now, processing has certain built-in variables. It keeps track of what is the width of my canvas, what is the height of my canvas, and conveniently names it width and height, which I appreciate. So I'm going to center this by putting it at width divided by 2 and height divided by 2. And this allows me to change the size of my canvas later. I can make a bigger animation, a smaller animation. All those things are fair game. And as a starting point, I know that I'm going to have a variable. This, by definition, is a variable star. So I'm going to do my radius as a variable. So I'm going to actually declare it up here. This is a typed language. It means that you have to tell the language. Is this an int? Is it a float? What kind of number? What kind of string am I dealing with? If I don't tell it, it gives me an error. And if I try, like I do in PHP all the time, to take that int and suddenly treat it like a string, it will not let me. So with this tightly typed language, I need to tell it, I have a radius. I'm going to make my radius a float so I can do more complicated math with it. I'm going to determine I can't type while speaking. And I'm going to give it lots of words, because the more precise I am, clearly the more I like my future self, because the code is more readable. So I'm going to start out, and I'm just going to initialize it as being equal to 0, so it has a value. Actually, I'm going to initialize it to 1. Now, the reason I did it that way is this is going to be how I modify the size of my ellipse. So I'm going to leave myself a comment. Use radius star to modify the radius by some amount. Less than 1 makes smaller, greater than 1 larger. So I'm going to have radius star times, so that's just a modifier. This is processing. It is a bastardized version of Java. Yeah, it's all right if you forget. I'm here to always answer your questions. So this is a bastardized version of Java. So I'm going to have radius star times. Now I'm going to make my star proportional to the size of my canvas. And in this case, because I'm thinking I'm going to add other stuff to the canvas later, I'm going to do width divided by 4. So this is the total size of my radius. Now, I could type all this math in here twice because I'm trying to make a circle. And I'm going to do that for the first try. Like I said, test everything and then move on. But it's kind of messy to have my equation in here twice. So I'll probably turn that into its own variable and pull it out. Okay, or not, because I can just figure this out as I go. Okay, anyways, let's test this and see if I successfully drew my circle in my canvas. And I did. Isn't this exciting? No, it's not. It's currently just a very boring circle in a black canvas. Now what I want to do is make this circle change over time. So I want it to get bigger and I want it to get smaller. And the way I'm going to do this is by essentially having what's called a phase. So the phase goes from 0 to 1 over time. And when a phase completes, the entire circle should repeat. This is exactly how we talk about actual pulsating variable stars. We talk about their phase and how they change in brightness over their phase. So my phase is where I am over time. And I'm trying to figure out how to explain this best. So phase goes from 0 to 1, and it is a fold of how the star changes over time. If you have a sine curve, you know it repeats over and over and over. Now, if I have something that's going as a sine wave over time, if I know the period of that sine wave, I can take all of that time and chunk it up according to the period and stack all of those bits on top of each other, and they just constantly repeat. So my phase is how things change over time, and it's something that repeats. It will make more sense as I work it out. So this tells me I need a variable that's an integer that's time. So I'm going to start at time equals 0 and just keep going. Now, if I wanted to have this be something where, let's describe the period. I'm going to make this an int again. So this is how long it takes for the object to repeat. The period is equal to, in astronomy, we tend to talk about periods in days, but we then measure things in seconds, which is kind of crazy of us. So I'm going to say that this is I want you to be able to see this. I'm going to give this a 45-second period, and I'm going to make a comment every 45, actually this will be frames, not seconds, so period 450 frames is every 45 seconds, or 450 frames. The star repeats. It's a pulsating, repeating what it does over and over and over variable star. Now, the other variable I know I'm going to need is phase, and this is going to be a float. Now, I'm going to be one of those anally retentive programmers that lines things up so that they're easy to read. Just to repeat what I've said before. Comments, all these little things. This is how you show that you like yourself, because it makes your code easier to read later. Or more to the point, you like your future self. I occasionally hate my future self. Okay, so I've set this up. I now have my variables for time, for period, for phase. And as a starting point, I'm going to pull up the processing information pages, reference pages, and I just want to see, do they have their sines and cosines going by degrees or by radians? And I'm just going to start off by having this oscillate as a sine curve once I know if it does it in radians or degrees. I don't know of any languages that use degrees, but it's always good to double check these things when you don't remember them. And there is no shame in looking things up. Come on, tell me where the sine wave is. There we go, sine. This is an angle in radians. So that is right here. So you can see I'm working in radians. Future self says thank you. Yes. Now, radians are not my favorite thing in the world. I'm going to admit that up front. Radians go from 0 to 2 pi. And so what I can do is, first of all, I'm going to put a note for myself. Radian, use radians, full circle equals 2. And they actually have special symbols where processing builds all of these constants into the language, so you don't have to worry about typing in pi. It has 2 pi. because this is designed for doing animations like this, it has you covered. I just wish it used degrees because my brain thinks in degrees. Okay, so I know I want to use radians. A full circle is 2 pi. Use sine function to get larger and then smaller over the cycle. This means, again, I'm showing that I like my future self, that 450 frames is equal to 2 pi. Because I already said that this was going to change over 450 frames up above. That's my period. So 450 frames equals period equals 2 pi. Now, we now have Doctor Who references going on. I totally approve. Okay, so now that I've left notes for my future self to prove to my future self that I do actually like her, I'm going to work on figuring out how to put this in a meaningful way. So my radius of my star is what I'm modifying. This is the amount that I multiply the width by so that it gets larger and smaller. Now, if I modify it by a sign that goes from 0, my star will go from 0 on out. That is rude to do to my star. Now, we're going to start from that though. So we're going to start by having our star disappear and come back. So what I'm going to do is radius star is going to be equal to, and okay, so my radius of the star is going to be equal to sine of my time value divided by my period. So at time equals 0, this is 0. And then the number gets bigger as it approaches 450 times the 2 pi. So I'm just doing essentially what fraction of 2 pi am I at as I approach my time. Now, the catch with this is I'm going to keep doing multiple radians, but because it's radians, it's down with that. It's going to happily repeat over and over. Now, this should work. In theory, as my starting point, I should now get a circle that is getting bigger and smaller and bigger and smaller. I often have bugs. This is why we test things every step. So here we go, testing. Give me my box. Okay, clearly I did something very wrong because I have nothing. Okay, let's see. So, oh, I didn't increment time. You have to increment time. So I'm at the end of each cycle, time gets increased by 1. I'm not sure if I'm River or Doctor Who in this scenario that you're discussing. I do, after all, have the book. So I'm incrementing time and nothing is happening. I wonder if plus plus isn't something that it knows. Time equals time plus 1. So that should get me to the point where I have something if If I wait long enough, I see nothing. That makes me sad. This is where we learn or remember how to output our things. So what I'm going to do is, because I'm now confused, I'm going to say print the value of radius star, and after you're done, put in a space. Okay, so let's see what it does. So that value is never changing. I have period is equal to 450. Time starts out as 0. Okay, so I know radius isn't incrementing. Is time not incrementing? Print time. Let's see. Time is incrementing. Am I just not waiting long enough? Okay. So I have sine of time divided by period. Let's make period, let's make all of these floats in case my conversions between floats and ints are killing me, which is entirely possible. Aha! I had a float versus int problem. Okay. Typecast languages are not my favorite thing in the whole wide world. Are you going to reverse directions? Why aren't you getting smaller? Okay, so it doesn't deal with... Why didn't it ever get smaller? Oh, because that gives it a negative width. So it can't have a negative radius. So if I set this going again, it starts at 0, and now when it turns around, it wants to start going negative, and it can't do that. Okay. So let's figure out how to modify things now. So 2 pi should be an internal definition. So for instance, here is the reference code that I'm looking at, where it has 2 pi just included in what it uses. Yeah, a negative radius is something not to aspire to. Okay, let me get that off the screen. So I have 2 different things that I want to worry about. The first thing is, I can understand why it doesn't want to get negative, but it doesn't seem to want to get smaller at all. So let me look at the numbers down here. So my timestamp, so these numbers are changing. Am I just not waiting long enough? Okay, while I start my code, I'm just going to leave this over here, doing its thing. And we'll see if it actually does eventually turn back around. It claims that it's, oh, I know what's happening. It's getting smaller, but it's not redrawing the background each time. So it's drawing on top of itself. It will hit negative and freak out, but it hasn't got there yet. So what I forgot to tell it to do was to redraw the background. And when you try and draw a smaller white circle on top of a bigger white circle, you see no change. So I'm going to tell it needs to redraw its background. And that means I don't need this command up here. Okay. So now it gets bigger. And then it should turn around and get smaller. And then it should try and have a negative radius and throw an error because you can't have a negative radius. Oh, that was unexpected. So it's treating the negative radius as completely valid. It's cool with having a negative radius. That's kind of funny. That was not... Dear Java, you do weird things. I guess it's just like changing where positive and negative are. Okay. There's a thing. There's a thing. I don't think we need a seizure warning because it's just a happy little ball. It's not doing anything too exciting. Okay. Now, with an actual pulsating variable star, they don't actually disappear on every pulse. That would be way too interesting. No, they actually pulsate only about 25% of the radius. So what I want is the amount that's getting modulated to only be at most 25% of the star. So that means I'm going to take 0.25 times this sign, and that tells me take the radius of the star and modify it by some factor related to 25. And this is all modifying my width divided by 4. So I have my starting amount, and then I'm going to expand that and contract it by an amount of 25% at most, if I did this right. So that is, I have to have a constant. I have to have a constant. Okay. So this needs to be 1 plus that amount. So what this says is the amount that I'm modifying it by gets added to or subtracted from some amount. Now, because this can go positive and negative, I now need to divide the 25% by 2. I will explain all of that in a moment. So let's see if this works. Oh, I created an oval, a very amusing oval that does not do what I want. This is what I meant by I at some point probably want to create a variable for the entire radius. So I'm going to have radius stars, my entire radius. And then I'm going to have radius mod. So this is how much I'm modifying the radius by. So let's come down here and call this the amount that I'm modifying the radius. And then I don't need this print statement anymore. So now the radius of my star is going to be equal to some number plus the amount that I'm modifying it. And I'm going to scale this by 1/4 the size of my canvas. So let me explain that. We're going to modify the star's radius by plus or minus the entire change I want is 25%. Since I'm going up and I'm going down, I'm doing 25% divided by 2. So 25% divided by 2. The sign is what's doing the modification. And then down here, I just need to put in the radius of the star. And now I should actually have a circle that varies. Welcome, Funmill. Star Trek Discovery. Do not abbreviate that show. No, that one you can't. No. Okay, I have a variable star that is varying a very small amount slowly. Why did it slow down? Well, because it doesn't have as far to go. Okay. So there goes my star, varying. It's not as exciting as it was because it's not varying as much. Okay, so I have a variable star. I'm pleased. The next thing to do is to get the colors on this changing. Now, right now, I just have a black and white image. So, since that's what I actually see in a telescope, what I'm going to do is, if I'm taking an image in the R band, the red image, as the star gets bigger, it gets cooler. As the star gets smaller, it gets hotter. So this affects a lot of different things. One of those things is how it actually appears. Another thing that changes is its actual temperature. Another thing that changes is its luminosity, which is a function of both temperature and surface area. So with a pulsating variable star like this, the amount of light that we see is changing for 2 reasons. One of those is the star's temperature is changing. The other is the star's actually changing size by a factor of 25%. So these suckers are doing a whole lots of crazy stuff. For now, what I'm going to do is I'm going to cycle through the colors in a way very similar to how I'm going to cycle through the radius. So now let's actually do this up where I set the colors up here. So color will change. Bigger equals more luminous and redder. And then smaller equals less luminous and bluer. Now, and I think this is where I'm going to end for today. So we're going to start with whiter equals more luminous. So we're going to start by having it get whiter as it gets bigger and having it get grayer as it gets smaller. And this means that we need to modify our color in a very similar way to how we modified our radius. So I'm going to take 255 and I'm actually going to take 200. Can I see 200 as a change? Let me see how gray 200 is before I do anything further. Yeah, that's pretty gray. I can see that. So I'm going to take 200 minus, let's add as a starting point, and add to this. I can get no more than 55. I'm going to do this as a ratio again. And so my ratio is time. Actually, no. I get my ratio from doing sine of time divided by period times 2 pi. Okay. So if I did this right, and I never know for sure if I did this right. Oh, it didn't like that. Am I missing a parenthesis? Yeah, I'm missing a parenthesis. Okay. And you can see it maybe getting lighter. Maybe I'm deceiving myself into thinking it's getting lighter. I think it's getting lighter. No, it doesn't. I can't tell. It seems to be getting darker. Yes, that's getting darker. Okay, so I've created a pulsating variable star that changes in shades of gray. Getting brighter as it gets bigger. So there we go. More luminous. And bigger, and now shrinking back down, getting less luminous. Now what I'll do next week is I'll figure out how to make this go, instead of shades of gray, have it get redder as it gets bigger and get bluer as it gets smaller. I have that book on my shelf, Fenmil, The Glass Universe. I still need to read it. So it was actually the Harvard women. They were also called Shapley's women, which is even more terrifying of a name. There was a group of women at the turn of the last century that worked at Harvard College Observatory in Cambridge, Massachusetts, as essentially human calculators. These were very well educated, very smart women who their parents essentially said, you're not marriage material, therefore go be scientists, which is a fascinating way of looking at life. Several of these women were actually hard of hearing. There was just a variety of different things in their life that made people think that they weren't marriage material, which meant they were allowed to go off and work at Harvard in the observatory. And Henrietta Leavitt worked on Cepheid variable stars that she was able to see in photographic glass plates that were taken of the Large Magellanic Cloud. And as she was studying the brightness of all of these stars that appeared to be at roughly the same distance, the same way everyone in New York City is essentially the same distance from me here in St. Louis, as she looked at all of these stars that were essentially at the same distance, she was able to observe that the stars that appeared brighter also took longer to change in brightness. The stars that appeared fainter were able to more quickly change in brightness. And folks that were working on trying to understand what drives stars, what powers stars, trying to understand their density, realized that the outer atmosphere of a star actually resonates in much the same way that a wave will resonate in any cavity. And the pulsations that we see are related to the size of the star in part. So what we're actually seeing is bigger stars take longer to pulsate, just like when you blow into a larger empty container, you get a deeper sound, which has a longer frequency, a longer wavelength of sound. When you see smaller stars varying faster, it's just like you get a higher pitched, faster frequency, shorter wavelength when you blow air into a smaller soda bottle. Waves work the same in cavities, whether the cavity is the atmosphere of a star, air in a bottle, or even what we refer to as the acoustic waves that oscillated through the primordial universe, creating the small knots of overdensities and underdensities of material that led to stars and galaxies and everything else. It's sound waves that drive so much of our universe. We always think about light waves, but it's sound waves that really matter, that we see in these pulsations and everything else. Anyways, I can wax on about this sort of stuff absolutely forever. It was kind of like the subject of my undergraduate thesis, the subject of my master's thesis. I would have done my PhD on it, but I was told there's no future in variable stars. Go forth and do galaxies. So I did. Next week, I'll start changing the color of this star. What questions do you guys have? What things do you want to ask me at this point? And I'll go over and switch views. So thank you all for joining me this evening while I worked on this. And I'd love to answer anything that I can for you guys. And I'll try and clean up my mess a little bit there. That might be slightly more readable. So any questions? This is where the stream lag makes things particularly interesting. Thank you guys for being here. Just to give you some highlights of some more things that are going on for those of you who joined late, which is always welcome. Join whenever you want. We're working with CosmoQuest to turn Twitch into your space for learning space. And this show is just one of many that we have going on on this channel. I will be back every Tuesday working on a variety of different programming simulation projects, trying to teach you different science. So Fenmill's asking, how did you go from variable stars and galaxies to planetary crater hunting? It's just software. So it started out where I was actually one of the people working on Galaxy Zoo 2. I was one of the founders of Zooniverse a million years ago. And a bunch of the missions that we were working with said that they essentially wanted someplace that had a lot more of an educational focus. And so CosmoQuest is a split-off project that was designed to have a lot of media features and a lot of other things that you don't necessarily see anywhere else. And so with CosmoQuest, we brought together Astronomy Cast, we brought together the Weekly Space Hangout, all under the umbrella of 365 Days of Astronomy, which is the CosmoQuest podcast. We were approached by a bunch of spacecraft saying, hey, I see that you guys know how to do software. Will you write a citizen science software to solve cratering problems? And software. I started out writing software to do variable stars. I went on to write software to reduce galaxy data. Now I write web interfaces to help you map out our solar system. And we actually will, with CosmoQuest, have projects involving galaxies coming up in the future. And I'm really looking forward to doing that. And it's one of these things where it's all about the concepts. For me, I'm applying software concepts to a variety of different problems in science. And not a lot of people who have PhDs in astronomy have a lot of chops for writing software. I think every astronomer knows how to be pretty tech literate. But the kinds of stuff we do with CosmoQuest are a different level. And I have a minor in computer science almost. Michigan State doesn't really offer that as a thing, but if they did, I certainly took enough computer science classes for it. Yeah, I took a bunch of computer science classes when I was an undergrad. I kept programming, and that landed me where I am. So I guess the key to everything is never stop learning, never be afraid to learn new things, and always think interdisciplinary, because you may end up going from freezing to death in a small observatory studying pulsating variable stars in our own galaxy to studying galaxies halfway across the visible universe on top of a distant mountain, to sitting in your home office using satellite data, which is the warmest of all of those options. So yeah, keeper of maps, you're right. Geography is like that. You apply the same concepts to all sorts of different things. GIS is I think Geographical Information Systems, is that acronym? It's one of those things that we even apply to other worlds. And Paranor T does keep one warmer, but the problem is you aren't allowed to have heat sources in domes. So you have your thermos, and when your thermos is empty, you have to walk where there are cougars and rattlesnakes from your dome to the dormitory where the kitchen is to get more hot tea. So sometimes you just decide you're going to be cold, because cold is better than cougars and rattlesnakes. It all depends on how brave you're feeling and how cold it is outside. I would often just huddle up if the wind was howling and I didn't feel like dealing. But if it was a nice calm night, yeah, I had all the tea in the world. Yeah, heat sensitivity is just one of those problems that you have to deal with when you're observing, because changes in temperature create eddies in the air, and telescopes see all of those things. Now, rattlesnakes are a problem mostly when they go out to sun in the evening and then don't slither far enough away. We actually had one of the other graduate students my first year observing. Luckily, she was super, super skinny. Rattlesnake that she didn't even see. She walked out of the dormitory and was looking up for clouds, not even looking down at all. It bit her pant leg and missed her completely. So don't wear tight pants while observing. Give the rattlesnake something to grab that is not you. I'm sure Hawaii has its own issues, lack of oxygen certainly being one. But yeah, I have been up to the Mauna Kea observatories, and I have to admit, I do not deal well with extremely high altitudes. And I've made that trip once, and I think I'm good. I think I'm good. And yes, rattlesnakes are a good reason to wear bell bottoms. That may explain cowboys. I don't know. But that was what I had planned for this evening. Thank you guys for all being here. And yes, we're going to launch a disco ball as a society into space, because it will be good for ham radio operators, and it's fun to watch people rant on Twitter about it. If you don't know what I'm talking about, Google disco ball satellite. It's kind of hilarious. So that's what I had planned for this evening. Our next stream is going to be tomorrow at 1 Eastern, 6 London, 10 Pacific, and it's going to be Matt Richardson. I don't know what project he's going to be working on solving. And yes, there's a ham radio aspect to the disco ball. It's great for bouncing signals off of so that you can wrap around the planet to new and interesting places. So tune in tomorrow for Matt. He will be back again on Friday. I will be here on Sunday doing telescope construction. And who knows, maybe there'll be some surprise feeds in between. My name, Dr. Pamela Gay, it kind of says it beneath me. I work for the Astronomical Society of the Pacific. We are all working on CosmoQuest. Don't know what to do with your night? Don't look at the news. You probably don't want to. Instead, go do some science. Go to CosmoQuest.org, and I'll see you around the internets. Have a great morning, evening, or afternoon, wherever you may be. Bye-bye.